The previous two examples considered a random variable that was discrete and it had two different possible mass values. This example will also consider a discrete random variable, but in this case there will be more than two mass values. Here's the example. Find the expected number of spots, and those spots, by the way, are known as pips. There is a name for everything, isn't there? Showing when rolling a fair die. Now, in this particular case, the first step is to define the random variable, and that random variable will be uppercase X, and that will be the number of spots showing on the upside of a fair die. The second step is to find the probability mass function of X, and that is going to be f of X. Now, usually I like to start over here on the far right and first of all determine the support and then come back and write the probability mass function. So the support in this case are all the number of possible values that X can take on, and you could get a 1 or a 2, 3, 4, 5, or 6 when you roll a fair die. The next question is, what is the probability that the random variable X will take on the value little x? And in this particular case, because it is a fair die, each one of these outcomes is equally likely. So f of 1 will be 1/6, and f of 2 will be 1/6, etc. This is often known as the discrete uniform distribution. The next step is to calculate mu, which is also written as the expected value of x. Now this x, of course, is uppercase. Since it is a discrete random variable, this will be the sum over the support of x times f of x. And the support in this case, script A, are the values 1 through 6. So this is the sum from 1 through 6 of x times f of x. Well, let's compute this summation. First of all, when x equals 1, the lower element in the summation, you are going to have 1 multiplied by f of 1. f of 1 is 1/6. Then when x is incremented to 2, you will have 2 multiplied by f of 2, and f of 2 is also 1/6. This will continue until you get 6, the upper limit, multiplied by f of 6, and f of 6 is 1/6. So we could factor a 1/6 out of all these terms, and all that is left is adding up 1 plus 2 plus 3 plus 4 plus 5 plus 6, and that is 21. Both 21 and 6 are divisible by 3, so 7/2, or 3.5, is the population mean, or the expected value of x. A way of interpreting this probabilistically is, if I roll a die over and over and over again, and I average the number of spots showing on each of those rolls, that will converge to this population mean, which is 7/2. I left a little bit of room here at the bottom because I think there is some value in seeing the physical interpretation of the expected value. So here are my outcomes, 1 through 6. And on the vertical axis, I'm going to draw the probability mass function f of x. And this will consist of a number of spikes, each of which has height 1/6. So that is your discrete uniform distribution. And some people might argue I should be just putting the dots up here, but I find these lines and drawing them as spikes a little bit easier to see what is going on. Next, the mean of this distribution is 7/2, which is 3.5, and that falls right here. So in addition to that probabilistic interpretation of 7/2, it also has a physical interpretation. If I were to have a barbell with a weightless bar, and I put a weight of 1/6 here at 1, another weight of 1/6 at 2, a weight of 1/6 here, all the way down, then this point right here, the population mean or expected value, is the point to where I would lift that barbell and be assured that it would not tilt to the left or tilt to the right. In other words, this 3.5 is the center of gravity for the barbell. So once again, discrete distribution, you can see that the mean has a probabilistic interpretation and it also has a physical interpretation as the center of gravity.